Now let us have another example with interest in some application. In this example, assume that X has a chi-square distribution. A chi-square distribution is characterized by this PDF. Obviously, you could verify that this is a gamma distribution. So this is a gamma distribution with parameters of, if you compare it with gamma PDF, with parameter of alpha equal 1/2 and lambda is equal to 2. So if you have a chi-square density of this formula, we say n is the degree of freedom. So this distribution arises when you do statistics. Now, for this case, if I apply this transformation, square root of my data, then using the previous example, you can quickly find that the distribution of the y will become this formula. This formula is important and interesting. A particular case of interest is the case that we have n equal 2 is a Rayleigh distribution. This is important in digital communication in some application. N equal 3 is important in the case of physics when you have a 3D space, like distribution of the distance of the hydrogen from the center of its atom. So you have a Maxwell distribution. Another example which has practical implication is the exponential function. So if you have this function, if I try to solve it y equal to e to the power of x, this one has always a unique solution. If y is positive, you have no solution. If y is negative, you take a log and you get one unique solution. So quickly I could say that fy of y is equal to 0 for y negative, and for positive values of y is equal to fx of ln of y, which is the solution, divided by derivative of this. Now, derivative of this function is equal to e to the power of x, which is y, so you divide by y. So for y being positive. So you get the PDF, instead of x, you get ln of x, and you divide it by y. For writing these 0 and so on, you can use the notation of unit step function, because u of y is defined to be equal to 0 for negative values of y and is equal to y for positive or equal value y. So this equality goes here. Okay. Now, an important case of this is where x has a normal distribution with mean mu, and that if you put that, then you get this distribution which is known as a log normal distribution. For instance, this distribution arises when you have water penetration under the ground, or contamination, or nuclear contamination, and so on. In digital communication, these represent some of the fading channels which are very bad, like shadow fading and so on. So the distribution of y e to the power of x is log normal when x has a normal distribution. This is why we call it log normal, because log appears here. Remember that we apply exponential function, but we get the log normal distribution, not the other way around.